For over a century, the foundational logic of probabilistic astronomy has rested on a single, almost unbearable certainty. The Milky Way contains somewhere between 2 and 400 billion stars. Of these, recent data from the Kepler and TESS missions confirm that the overwhelming majority host planetary systems, and a statistically significant fraction of those planets, reside within the habitable zone where liquid water can exist on a rocky surface. The mathematics, refined by Frank Drake in 1961 and sharpened by every subsequent decade of observation, is not subtle. Even under the most punishing assumptions, even if we assume that abiogenesis is rare, that complex life is rarer still, that intelligence is a freak accident, and that technological civilizations destroy themselves with monotonous regularity, the galaxy should still be teeming. A single civilization, expanding at a mere fraction of the speed of light using self-replicating von Neumann probes, could colonize the entire Milky Way in somewhere between 5 and 50 million years. Against the backdrop of a galaxy that is 13.6 billion years old, this is not a long time. It is a rounding error. The galaxy has had, by conservative estimate, more than 1,000 opportunities to be saturated with intelligence before our sun ever ignited. The sky should be screaming with radio chatter, glittering with Dyson swarms, structured by megastructures whose infrared signatures we cannot miss. This is the established rule. Intelligence, once it arises, expands. Expansion, once it begins, does not stop. And then there is the silence. Not a quiet sky. Not a sky with a few suspicious gaps. A silence so absolute, so mathematically improper, that Enrico Fermi, standing at a Los Alamos lunch table in 1950, could only ask the question that has haunted physics ever since. Where is everybody? 75 years of increasingly sensitive radio surveys, optical SET-1 sweeps, infrared scans for waste heat from stellar engineering, and targeted observations of anomalous stellar dimming have returned exactly nothing. Not a probe, not a signal, not a single, unambiguous artifact. The universe, by every measure we have, is behaving as though we are alone in it. And that behavior is not merely strange. It is a violation of the priors so severe that some statisticians now place the Fermi observation among the most anomalous data points in the history of empirical science. The mainstream explanations have been examined one by one, and one by one they have failed. The rare Earth hypothesis, advanced by Ward and Brownlee, argued that the conjunction of conditions required for complex life, a stabilizing moon, plate tectonics, a Jupiter-class shepherd, a quiet stellar neighborhood is so improbable that Earth may be effectively unique. But the discovery of thousands of exoplanets, including a growing population of rocky worlds in stable orbits around long-lived K dwarfs, has eroded this argument from beneath. The galaxy contains too many stars, and statistical uniqueness collapses under the weight of large numbers. Even if Earth-like worlds are 1 in a million, the Milky Way should host hundreds of thousands of them. The Great Filter Hypothesis, articulated by Robin Hanson, proposed that some step in the long ladder from inert chemistry to galactic civilization is so improbable that almost nothing crosses it. Perhaps abiogenesis itself is the filter, in which case we are fortunate beyond comprehension. Perhaps the filter lies behind us, in the leap from prokaryotic to eukaryotic life, an event that on Earth required nearly 2 billion years of stagnation. But the filter argument is a knife that cuts in two directions, and the more we learn about the resilience of life extremophiles thriving in volcanic vents, organic precursors detected in interstellar clouds, amino acids embedded in meteorites, the less plausible it becomes that the filter lies safely behind us. Which leaves the colder possibility that it lies ahead. The zoo hypothesis, in which advanced civilizations deliberately abstain from contact to allow younger species to develop unmolested, requires a coordination across thousands of independent civilizations spanning millions of light years. It is not merely improbable, it is sociologically incoherent. A single defector, a single rogue probe, a single careless transmission would shatter the embargo, and in a galaxy of billions of stars, the probability of perfect compliance approaches zero. The dark forest hypothesis, popularized by Lou Sixon, suggests that civilizations remain silent because announcing one's presence is suicidal. But silence does not explain the absence of accidental signatures, the waste heat, the stellar engineering, the unavoidable infrared fingerprint of any sufficiently large industrial economy. You can hide a transmitter. You cannot hide a Dyson swarm from the laws of thermodynamics. Self-destruction, the comforting middle school answer, fails on the same grounds. Even if 99% of civilizations annihilate themselves shortly after achieving radio capability, the remaining 1%, multiplied across the galaxy and across deep time, should still be visible. A single surviving civilization, with a head start of even 1,000,000 years, should have colonized the local cluster. The transcension hypothesis, in which advanced civilizations ascend into computational substrates indistinguishable from black holes or vacuum, is unfalsifiable in a way that makes most physicists uncomfortable, and it does not explain why the transition would be universal. Some civilizations, surely, would remain interested in the macroscopic universe. Some would expand for reasons we cannot anticipate. Even one would be enough. And so, having exhausted the comfortable explanations, the field has begun to drift toward conclusions that were once considered the province of metaphysics. In 2024, a team analyzing the Bayesian implications of the continued silence published a paper in the Journal of the British Interplanetary Society arguing that the posterior probability of the simulation hypothesis, the proposition that our observable universe is a constructed environment, rises sharply with each null result from SETI. The argument is uncomfortable in its precision. If intelligent life is common, we should see it. We do not see it. Therefore, either intelligent life is so vanishingly rare that we are effectively alone, which contradicts everything we know about the prevalence of organic chemistry, or the universe we observe is not the universe that exists. This is where the terror begins to acquire mathematical structure. Consider the implications: the cosmic microwave background, the distribution of galaxies, the apparent age and scale of the observable universe. All of these are computationally cheap to render at the resolution we can currently measure. The expensive part of any simulation would be the rendering of unscripted, autonomous, intelligent agents. A simulation optimized for computational economy would contain exactly one civilization, observed from exactly one perspective, with the rest of the universe presented as a high-fidelity but ultimately empty backdrop. The Fermi silence, under this reading, is not a sociological mystery. It is a rendering decision. The stars are there because we look at them. The civilizations are not there because no one has asked the simulation to compute them. There are stranger possibilities still. In the many worlds interpretation of quantum mechanics, every observation branches the wave function, and an observer always finds themselves in a branch consistent with their continued existence. The anthropic logic of quantum suicide, extended to civilizational scale, suggests something called quantum immortality of observers, that we find ourselves in a precise branch of the multiverse where no other civilization arose to interfere with our development, not because such branches are common, but because they are the only branches in which we exist to ask the question. Every other branch, the vast majority, contains a galaxy already colonized, a sky already saturated, an Earth already absorbed into someone else's project 1,000,000,000 years before our Sun condensed from its primordial nebula. We are not alone because aloneness is likely. We are alone because aloneness is the precondition for our being here to observe it. And there is the worst possibility, the one that working astrophysicists discuss only in private, the one that gestures toward a structural failure in the physics itself. The continued silence may indicate that the cosmological assumptions underlying the Drake equation are wrong in a way we have not yet diagnosed. Perhaps the speed of light is not merely a limit, but a containment. Perhaps the universe is not isotropic on the scales we assume. Perhaps the apparent age of 13.8 billion years is an artifact of our position in a much younger or much stranger structure, and the sky appears empty because the conditions for intelligence have only existed in any branch of the cosmos accessible to us, for a span far shorter than current models permit. Under this reading, the silence is not the absence of neighbors. It is the signature of a physics we have catastrophically misunderstood, and the universe we believe ourselves to inhabit is a partial, distorted, perhaps deliberately falsified projection of something else. In each of these scenarios, the rendered simulation, the anthropic branch, the broken cosmology, the operative truth, is the same. The silence is not data about the prevalence of life. It is data about the nature of reality, and the data are converging, slowly, toward a conclusion that no one in the field is yet willing to write in a grant proposal, but that increasingly appears in the marginalia of late-night conversations and in the careful hedges of review papers. The Fermi Paradox may not be a paradox at all. It may be the loudest signal we have ever received, and it may be telling us that the universe we see is not the universe that is. There is a particular kind of vertigo that comes from sitting with this for too long. The night sky, viewed through this lens, ceases to be a vast and indifferent expanse and becomes instead something far more intimate and far more disturbing: a constructed surface, a curated absence, a set of empty rooms arranged for an audience of one. The galaxies are there, the stars are there, the planets are there, in their billions, with their oceans, in their atmospheres, in their patient, unhurried geochemistry, and nothing else. No probes, no signals, no swarms, no engineering, no echoes, just the steady, unanswered hiss of the cosmic background and a mathematics that should not, by any honest reckoning, produce a sky like this one. The working physicists I know who have thought about this seriously, and there are not as many as you would expect, because the question has a way of unsettling careers, tend to arrive at the same posture. They stop talking about it in public. They develop a quiet preference for shorter timescales and smaller questions. They publish on stellar nucleosynthesis and exoplanet atmospheres and the chemistry of protoplanetary disks, and they avoid, with a care that becomes its own kind of evidence, the larger question that hangs above all of these smaller ones. Because the larger question, asked honestly and answered honestly, leads to a place from which the practice of normal science becomes very difficult to resume. The galaxy should be full. It is empty. The mathematics that says it should be full is the same mathematics that produced the satellites in our orbit, and the chips in our phones, and the models that predicted gravitational waves a century before we detected them. That mathematics is not wrong, which means something else must be. We were taught, all of us, that the cosmos is vast and ancient and indifferent, and that our task as a species is to look outward bravely into that vastness and find our place within it. But the vastness is not answering. It has not answered for 75 years, across every frequency we have learned to listen on, and the implications of that non-answer are becoming, with each passing decade, more difficult to contain within any framework that leaves the rest of physics intact. Perhaps the answer is simpler than any of this. Perhaps we are, against all probability, the first. Perhaps the filter is behind us, and we are the rarest thing in the universe, the firstborn of a galaxy that will one day be loud with our descendants. That is the hopeful reading, and on good days, it is the one I prefer. On the other days, I think about the silence, and about what kinds of universes produce silences like this one, and about how very few of those universes are the kind we thought we were living in. And on those days, the night sky does not look empty. It looks watched.